Hi, everyone. It's Dan Sandick here with the Institute for Catastrophic Loss Reduction. We'll just give everyone a few seconds to join, and then we'll get started. Hi again, it's Dan Sandick here from ICLR. We're about 1 minute after the hour, so we'll get started. So thank you everyone for joining us today. I'm here hosting today with my colleagues Eric Sparling from the Climate Risk Institute and Katarina Lotson and Ben Hudick from GIZ. Together with the Ontario First Nations Technical Services Corporation, ICLR, TRI, and GIZ, we comprise the PIEVC Alliance. Claire Sanders from the Climate Risk Institute is today's Zoom host. If you have any audio or technical issues, please message her directly through the chat. Or if you have any questions about this webinar series, please connect with Claire through the chat. Note that we're recording the webinar today, and we'll be sending out a link to anyone who has registered. The recording will also be posted to the PIEVC Practitioners Network, and we'll give you an opportunity to join that a little bit later on as well. We want to especially welcome those of you who are joining from outside of Canada. Today, I'm joining you from the traditional and treaty territory of the Mississaugas, specifically the Mississaugas of Scugog Island First Nation, signatories of the Gunshot Treaty of 1788 and the Williams Treaty of 1923. We welcome you to introduce yourself via the chat. You could tell us where you're from and add a land acknowledgement if you would like. So next slide, please. This webinar is part of a webinar series focused on the PIEVC protocol and its application. And this webinar series is leading up to the in-person PIEVC Global Forum in April, which will be hosted in Vancouver. If you've missed any of the earlier webinars, the recordings are available on CRI's website, and Claire is going to put a link into the chat. Next slide, please. So this webinar is actually the second part, part B, of a webinar that we hosted on January 19th, which focused on application and case studies associated with the PIEVC High Level Screening Guide. So the PIEVC High Level Screening Guide was released just about 1 year ago this month. Currently, we have well over 400 registered users, and we're using these webinars to give the PIEVC community, participants, an idea of how the High Level Screening Guide has been used in the field to date. We hope to continue these discussions going forward, notably at the PIEVC Global Forum in April. During the webinar in January, we had a very quick introduction to the High Level Screening Guide itself from Jeff O'Driscoll, and 3 case studies, which are listed there. And again, all of this full webinar is posted on the CRI website as a recording. So feel free to provide more context on the High Level Screening Guide itself. You could access that video recording at any time. And today we're going to talk about 4 additional case studies, which we'll be getting to shortly. So one note is that we had an additional presentation scheduled today from a participant from the BC Climate Action Secretariat, who is going to be talking about the Climate Resilience Framework and Standards for Public Buildings document and guideline, which was recently completed. So we're going to drop that document into the chat so you can review that. And we understand that the BC Climate Action Secretary is going to be participating in the Global Forum, and we hope to hear more about that guideline, which includes references to PIEVC products at that time. So speaking of the Global Forum, next slide, please. We are happy to note that the registration for the Global Forum is now open. The forum will be held at the Sheraton Wall Center in Vancouver on April 18th, 19th, and 20th. The forum is going to include 2 days of keynotes, panels, breakouts, and working sessions with a third day dedicated to site visits around the city of Vancouver. And Claire is going to be sharing a link for the registration in the chat as well. And we hope that everybody on the line has a chance to register and will join us in Vancouver in April. Next slide, please. So we also wanted to note that there is a PIEVC course offered by Climate Risk Institute in partnership with Royal Roads University that is starting next week, and you are still able to register if you're interested. This is a 5-week course that includes both self-directed, self-paced learning and live sessions with instructors. And Claire will also be providing a link for registration to that course in the chat. So back to today's webinar. So we're very happy to have Quentin, Glenn, Abhishek, and Lindsay here to talk about some of the work that they've been doing. We're very happy to have them here today. After the presentations, we're going to have some time for questions and discussion. We've asked that any time throughout the webinar, you enter your questions into the Q&A box or into the chat box. And unless there's something very specific to a presenter, for example, a really specific clarification question, our plan is to hold all questions until the discussion period after the presentations. And if there's any questions that we can't get to, certainly last webinar, we had many dozens of questions that we didn't get to during the webinar. This is one reason why we'd like participants to join the free, freely accessible online networking space that's hosted through the PIEVC Alliance. And certainly discussion can continue there. And just a note to remind our presenters, we're aiming for about 12 minutes for presentations, and we hope to save some time at the end of the webinar for discussion. So without further delay, we're going to introduce our first presenter. So our first presenter is Quentin Chiotti. Dr. Quentin Chiotti has been working in the field of climate change risk and resiliency for almost 30 years as an academic, for the nonprofit sector, for different levels of government, and for the private sector. Currently, Dr. Chiotti is practice lead climate risk and resilience at Matrix Solutions and teaches a climate risk course at the University of Toronto Scarborough campus. Before joining Matrix Solutions, Quentin was senior advisor, sustainability and subject matter expert, climate risk and resiliency at Metrolinx from 2015 to 2021. So thanks again, Quentin, for joining us, and I'll pass the mic to you.
Great, thank you, Dan. So the title of my presentation, Applying a Relative Measure of Likelihood to Climate Risk Assessment, PIEVC High Level Screening Guide at the Municipal Asset Level. I do want to give a shout out to my colleagues and co-authors, David Van Vliet, Tara Romuliotis, and Melanie Ivy Sampson. Sorry, that was dry mouth. That wasn't difficulty in pronunciations. Before I go to the next slide, don't run ahead of me, Claire, is that I do want to provide a traditional land acknowledgement. Acknowledge that the land I'm presenting from in Toronto is situated on treaty land that is steeped in rich Indigenous history and is the traditional territory of many nations, including the Mississaugas of the Credit First Nation, the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis communities. We are grateful to have the opportunity to work and live on this land and share responsibility for its stewardship. Next slide. So when I go through the PIEVC High Level Screening Guide, the list of how and where the process can be applied really stands out to me, especially in regards to activities that pertain to municipal decision-making, such as the operation and maintenance of infrastructure, asset management, and also climate vulnerability and risk assessment. Another part of the high-level screening guide that stands out is the probability scoring method, which struck me as a major improvement over alternative methods that have been widely adopted elsewhere across the climate change community. This got my colleagues and I thinking about likelihood scoring methods and their role in helping municipal decision makers better understand climate risks. And we found this to be the case during the process to develop a climate adaptation plan for the city of Guelph, where our approach has been to apply a climate risk assessment onto infrastructure assets and the services that they provide. It is our experience that the high-level screening guide probability scoring method strongly resonates with municipal decision makers. Next slide. So why is this the case? When we look at alternative scoring methods, likelihood scales can be challenging to understand, if not confusing, especially when you're having to compare future projections to historical conditions. The result is confusing method 1 plus confusing method 2 equals a confused stakeholder with an unrelatable understanding of climate risks. Next slide. Not only does the same situation occur in examples of municipal climate adaptation plans, but there is in fact a wide variation in how likelihood is defined and applied when you actually scope out, examples of municipal climate adaptation plans. For example, at one extreme, likelihood can be presented qualitatively, or in some cases, none at all. While at the other extreme, likelihood can follow the IPCC method, which is difficult to get your head around. And even in the case of plans that adopt the ICLEI-BARC framework, which is being widely adopted across the country among municipalities, we found that there is no consistency and subtle differences can occur. For example, we found that the likelihood rating for possible to rare can be marginally different, when the likelihood may arise once in 5 years versus once in 10 years, or unlikely during the next 10 plus years or during the next 25 years. So for some decision makers, such differences may not be significant, but to someone who is operating, maintaining, and managing infrastructure assets, which are vulnerable to climate hazards that accelerate deterioration, how one defines likelihood can become critically important. Next slide. Using alternative methods to calculate likelihood seems to be okay when the climate risk assessment exercise is high level. So for many municipalities in particular, or especially, that may work fine, such as when your impact statements are thematic or aligned with goals, involve numerous departments, result in a wide range of actions, and are informed by an array of plans, policies, and strategies. I note that among what I would call the first generation of municipal climate risk assessments, that infrastructure assets and services and asset management plans were considered amongst the mix, but not generally prominently addressed. Across municipal climate adaptation plans, the types of actions can be numerous and wide-ranging, involving planning, communications, operations, etc., and where asset management can get lost in the shuffle. So for example, the number of actions that I've seen across different municipal action or adaptation plans have ranged from around 50 to well over 400. So how do you get your head around such a range of actions and make it meaningful and achievable within a planning context? But if the focus is on infrastructure assets and the services they deliver, then there is a stronger common thread that ties impacts and actions rather together around operations and maintenance, around asset management, and presents an opportunity for the high-level screening guide probability scale to play a more prominent role. Next slide. In recent years, the integration of climate change into asset management planning is also becoming more prominent as a legislative requirement in Ontario, but it is also beginning to appear on the radar in other jurisdictions, agencies, and in the private sector. In this context, I would like to acknowledge the good work being done by the Federation of Canadian Municipalities, FCM, and also by ICLEI as examples of this trend. And I want to highlight the work being done by FCM in particular and their fact sheets that provide a clear and concise pathway as you work your way through the risk assessment process, from considering climate hazards through to identifying resiliency actions for key types of infrastructure. Next slide. Now, I don't expect you to soak in all that what's on this very populated table, but they are examples of different types of infrastructure and how to manage climate risk through enhanced asset management as articulated by the FCM fact sheets. This slide provides further detail when the focus is on infrastructure assets as it applies to climate hazards, asset failure, impacts to levels of service, and indirectly the costs associated with response measures. Of note is the focus on operations and maintenance, on renewal and even replacement options, which can then be further refined as taking action on adaptation, on mitigation, or on actions that generate co-benefits for both. And from our experience, I think this is a good way of trying to bring together the race to zero, which many municipalities have given a higher priority relative to the race of resiliency, into one comprehensive approach. Next slide. So this comes back to the role of likelihood in fostering our understanding of risk, and this slide outlines the likelihood probability method adopted in the high-level screening guide in all of its glory and all of its detail. So I find that when you try to get your head around looking at the relatable and relative likelihood of future climate conditions compared to the past, that this is actually a method that is much more relatable to decision makers amongst municipalities. And it has been our experience that the probability scoring method adopted in the high-level screening guide is an effective method that resonates with municipal decision makers who are responsible for the operation, maintenance, and management of infrastructure assets. So the question is, why does it resonate? And operations and maintenance activities tend to be focused on the here and now. They tend to be temporally more immediate, and at best, looking ahead through capital planning cycles, perhaps 5 or 10 years into the future. And there is also historical experience that is hard to ignore, even though as science-based practitioners, we are taught to preach that past experience is not a good indicator of future conditions. But when you own, operate, and manage infrastructure assets, the reality is that history matters. Next slide. So to what extent then is the past a good or bad indicator of the future, especially when recent extreme weather events that can fall well outside of the realm of normal probability, such as a 1 in 500 year event, or even multiple 1 in 500 year events, have occurred or reoccur, and in some cases are not even captured in climate change projections. As weather and climate becomes warmer, wetter, and wilder, we can expect that extreme events and their impacts on infrastructure assets will be experienced by more and more decision makers, and that these experiences will greatly influence their perceptions of future risk. So perhaps a pragmatic pathway forward is the combined experience with past extremes, with future projections, noting that the unexpected is still possible and that bad history can repeat itself. So this places great importance on the relative change in likelihood. Next slide. And this is just one theoretical example that I'd like to share with you, noting that relativity, when you try to understand future climate relative to the past, has some challenges that you need to note. So this is a practical example of the likelihood scoring method. In one case, when the risk score is high, and another when the risk score is medium, if you're doing a municipally based climate adaptation, vulnerability, and risk assessment. Heavy rainfall and flooding has a high score in this example of 16. Culverts are at high risk, for example, where there is increased flood risks associated with the likelihood increasing between 10 and 50%. One would expect that the municipal response might be to increase operations and maintenance resources and procedures, and put in place higher design standards when constructing new stormwater management systems. In the case of freeze-thaw cycles that are projected to become less frequent, dealing with potholes and rolled surfaces that are at medium risk or a risk score of 6, decision makers are facing decreased costs for repairs, since likelihood will decrease between 10 and 50%, and as a result will not appear with a risk score of 6 as a high risk that requires attention as an outcome of the risk assessment. So typically when you're doing risk assessment exercise, it's the high or the very high risk that you focus on, and all the medium risks and the low risks tend to get brushed aside. So how does that apply in a asset management context? Based on historical experience and current practice, let's say repairing potholes, for example, may already be a significant problem that city staff are managing well, and thus changes in practices and budgets in the immediate future may not be necessary. The issue then becomes where tweaking of O&M, asset management, and capital planning budgets as required. Do their needs increase? Do they decrease as projected? Next slide. Final thoughts. I would make the case that the PIEVC High Level Screening Guide and the likelihood scoring method can be an effective tool in informing municipal climate adaptation planning, especially for assessments that focus on infrastructure assets. And while this may be an important improvement in itself, it could also become an important step towards taking a deeper dive into incorporating climate change impacts into asset management planning. In the latter case, we should acknowledge the great work being done by and for the Financial Accountability Office of Ontario and the potential further application of the High Level Screening Guide probability scoring method, if not the overall guide process itself. Next slide. If you have any questions or care to follow up, don't hesitate to contact me directly.
Great, thank you very much, Quentin. Very interesting points, and we look forward to continuing this discussion at the end of the webinar. Hopefully, as people are watching, they're getting a chance to consider their questions, what they'd like to discuss with Quentin and our presenters. And as we mentioned before, please enter those questions into the chat at any time. Claire, if you wouldn't mind advancing to the next slide, we'll do a quick introduction of our next speaker, and we'll move along. So our next speaker is Glenn Milner. Glenn Milner is a senior manager leading climate resilience with Jones Lang LaSalle, JLL, a global real estate services company that specializes in commercial property and investment management. As an environmental engineer specializing in climate risk, his experience is multidisciplinary and extends across many sectors, including commercial and industrial real estate, energy, water resources, transportation, supply chain management, and policy development. Glenn has worked on climate risk, resilience, and sustainability initiatives across Canada, the United States, and more recently has focused on assessing and reducing risk within investor organizations and across global real estate portfolios. So thanks very much, Glenn, for joining us, and I'll pass the mic to you.
Great, thanks, Dan. Quick audio check that you can hear me all right. I'm assuming so.
Yep, we're good.
Perfect. All right. Well, thanks very much for having me, and I appreciate the introduction. I'm really kind of pleased to be here today to share a bit of a different perspective on how the PIEVC High Level Screening Guide can apply to infrastructure systems and specifically real estate portfolios held in various regions across the world, and its applicability in different contexts. So I'll just start, if you go to the next slide there, Claire, with a brief overview of where I'm coming from. I won't go through all this, but JLL, or Jones Lang LaSalle, is a global company. We have presence in 80 countries and a staff of 100,000 people across the world. So part of my excitement in thinking about the PIEVC process and the High Level Screening Guide is how it can relate and scale up to some of the size and extent of these corporations working on real estate, as well as managing infrastructure at all sorts of scales and different regions. We're very kind of conscious about how sustainability and how specifically how resilience factors in at all stages of the real estate cycle, which I'll speak about in a little bit. Next slide. So I did want to start just by defining what one archetype type of portfolio could look like across a discussion with partners and with clients from my perspective at JLL. When we speak about a real estate portfolio, this can look very different. This could be, for example, someone who owns, operates, or manages infrastructure within one region or one city. It could be someone who owns or has access and manages, let's say, a handful of assets across 2 different regions. Or it could look like this, where they own and operate infrastructure across various regions of the world. And I've given you just a sense of the types of asset classes that are often in these conversations to figure out how will we, assess the risk and prioritize. How does this feed into decarbonization efforts and sustainability initiatives more generally? And typically we are talking about offices, retail spaces, multifamily and single family residential facilities and buildings, industrial and logistics, hotels, and other mixed use type of assets. So I'll just pause there and let you kind of reflect on how important that can be in the context of achieving resiliency, particularly in terms of making sure the outputs of a risk assessment feed into what they need to actually inspire action. And that's a big part of what I'm advocating for in this role at JLL, is taking things beyond simply being aware of risk to understanding what you can actually do about it. And just to give you a couple of factors there at the bottom of the slide, you can see there the importance of real estate in Canada and in the US more generally, as well as a big factor, I would say, in scoping climate change risk and resiliency type of studies is whether something is majority owned from a particular investor or client versus something that may be co-invested or a joint venture investment. Those conversations can look quite different, for example, if you're working with an owner of a real estate or infrastructure versus someone who is occupying or leasing that asset. So next slide. I did want to speak a little bit about the real estate context in terms of what can drive interest and action in risk and resiliency types of work. Perhaps it doesn't go to surprise you that asset value is very important to investor clients from our perspective. And apologies for the font size on this slide, by the way. But critically, I would say risk mitigation and really ensuring cost savings and cash flow optimization is very important for people who own these assets around the world. And you can see there just a couple of statistics there on the right-hand side that JLL has pulled together more globally, but you can see there some of the cost savings that can be achieved with types of sustainability initiatives being undertaken. And this can include resiliency assessments or risk assessment for a particular asset. Quite important as well is the outcomes of a risk assessment as it relates to favorable financing, incentives, and actually using that information to ensure that on an ongoing basis, operations and capital upgrades are made in an intelligent manner, for example. Next slide. Perfect. I did want to speak briefly too that the real estate industry is changing. It has been quite significant depending on the region and the country in which it's kind of being discussed. But globally, we're seeing trends in various different ways. And this slide just provides several different ways of kind of slicing and dicing that up. Obviously, perhaps no surprise to everyone on this webinar today, we're seeing increasing in extreme events impacts and billion-dollar disaster events, for example, in the States. We're also seeing increasing interest and sign-on into a number of global initiatives as it relates to reporting, sustainability, commitments. And the two on the right-hand side of this slide, I like to kind of emphasize, which are the amount of specifically venture capital investment heading into green technology and debt issuance as it relates to global sustainability. We're seeing that rise, and I'll speak to how private sector kind of climate tech companies are also increasingly present in the role of the data component of risk assessment for climate hazards, and what that may mean for moving forward with making sure robust approaches are continued to be taken. Next slide. There is a huge opportunity for action in this space. I hope just by some of those figures and some of the scale of these portfolios that gets you to think about the opportunity here. just to re-emphasize that 9.6 out of 10 commercial real estate owners and occupiers have set kind of publicly stated goals as it relates to sustainability, many of which are decarbonization targets, but even so, they are expressing that commitment publicly to take more of a conscious action towards sustainability. 9 out of 10 have goals that will expire in the next 3 years, and only 2 out of 10 have an action plan or have actually dedicated or committed capital to achieving those goals. And so that's part of the mandate and the opportunity really to move from disclosing and understanding risk to actually using that to inform these decisions that are going to be a priority moving forward. And a big part of what that looks like is embedding risk assessment outputs, particularly that could be completed through the high-level screening guide into, for example, decarbonization, upgrades of assets, or decisions that are happening more strategically across portfolios. Next slide. And so I did want to speak to kind of how the PIEVC high-level screening guide can come into this process. And this can be quite an important conversation, but there are a number of factors that look relatively distinct or unique from the real estate perspective that I wanted to emphasize here in red. And you can see there that the font in black on this slide are kind of core components to what you'd expect from guidance as part of the PIEVC screening guide. And the font in red is stuff that it does speak to, but it's a bit unique as it relates to the real estate context. And so very, very kind of upfront as part of the scoping initiative of a portfolio application, we have to think about ownership. And I know this is a big piece of the guide itself, but we have to think about, for example, will joint venture or kind of co-invested assets be included as part of an assessment across a portfolio of assets? And where will the assessment fit in as it relates to due diligence or site acquisition for new assets as it relates to existing portfolio kind of priorities? I would also emphasize that we have to reinforce ambition right up front with a lot of these investor clients. And that's an important component to the work we do, is making sure that they aim high and that they understand that it's not only about picking, let's say, several assets that may be perceived to be higher risk, but understanding holistically there's a need to understand that exposure piece and the likelihood of those impacts first and foremost. From a data perspective, as it relates to what climate projections are used and how likelihood scoring is undertaken, there is an added complicating factor there with folks who may be tempted to divest particular assets from particular contexts. But I would say the bigger factor is the rise of private sector climate technology companies. There are probably about 10 of these across North America now that are providing hazard analytics data or climate model data that need to be kind of cross-compared to projection information from climate modeling. And it's a very important piece of an assessment to make sure that you're using the most appropriate data for the appropriate region that you're hoping to undertake an assessment for. So that's a pretty big limitation or caveat to know kind of what data you may be acquiring or using in this space for real estate portfolios. From an assessment and reporting perspective, I think the screening guide is well tailored to the needs of real estate portfolios, and there's huge opportunities to, once you're completed the process, actually pilot some of the opportunities for adaptation to specific sites. You'll often get questions around costing, of course, and you can kind of speak to how that needs to come as a next step, but that's an important part, of course, of those who invest in assets to understand how much it might cost now and what the ROI might be on that moving forward. And finally, the adaptation components to the real estate portfolio side of things, there's a number of mechanisms and programs that these outputs could feed into. There could be data monitoring programs already in place across these portfolios. There are software systems that are used already in terms of monitoring and warnings in some cases. There's a number of initiatives around decarbonization and assets that are actually being allocated funding for certain upgrades that can be embedded into with the results of the assessment process. So I'll leave it at that. But next slide. I did want to speak to one critical component of the high-level screening guide process as it relates to portfolios, which is archetypes. This just gives you a very simplified visual illustrating what it could look like across a portfolio. And this is just based on some discussions with one particular investor in North America to date, and is not meant to be quantitative. But the idea here is we're trying to help them understand what may be most representative for their particular portfolio. And do they have to assess everything everywhere, or is there a way to kind of find profiles of assets that may be able to be extended or expanded across a portfolio in similar contexts? And this, I think, is where the high-level screening guide is very, very valuable, is understanding how do you define archetypes, what is appropriate, what's not appropriate, and how do you have to take a multi-hazard approach to understanding those risk profiles across a portfolio. Next slide. And I spoke to this a little bit at the beginning, but as I said, risk assessment and adaptation really can inform all or very, very many phases of the real estate cycle. So if you look at that figure there on the right, that is a typical real estate cycle that we operate within at JLL. And you can see just how diverse that can be, from strategizing about portfolio locations, to acquiring sites, to planning, capital upgrades, design and engineering, to energy and sustainability related decision-making, to leasing. All these types of things can have adaptation actions that can be informed by risk assessment outputs. And I think it's important to recognize and build confidence in the high-level screening guide approach to avoid kind of folks thinking they have to do very detailed approaches one at a time to help them understand how it may be transferable across the board. Next slide. And finally, I'll just leave you with a couple of key takeaways from this presentation. And I hope this was an interesting lens to apply on the high-level screening guide as we kind of further develop what it could look like in this space. This decade is being seen as the most important time to decarbonize the built environment. And there's a huge role for climate risk to be factored in there to actually kind of take part of this action, especially as upgrades and capital is being dedicated to assets across the world. We are seeing there's a need to build confidence among portfolio owners to take risk-informed approaches and not necessarily just stop at risk disclosure, which has been the case, I would suggest, in the past decade. So to kind of inspire that confidence moving forward with robust frameworks such as the guide. Leveraging and applying this guide, for example, specifically as the rapidly market of real estate grows as it relates to sustainability, is a great opportunity. And a near and dear issue related to my heart is sharing examples where appropriate and possible from the private sector is a very helpful way of kind of looking at what's worked well, what are the lessons learned. And the last two, I'd suggest, and I spoke to this a little earlier, there is a large supply expected of climate-related data and technology companies coming out, specifically targeting real estate. And I think it's going to be very important to look at these with a grain of salt and to make sure you understand the methodologies and interpret this with limitations and the outcomes in mind, and perhaps doing some cross-referencing with the projections that are already out there publicly and where they may be appropriate for use. And most importantly, we can't do this alone. These are huge organizations involved in investment in real estate, but they cannot be responsible and should not be responsible for assessing risk across these portfolios in isolation. And so it needs to be collaborative, much like the guide speaks to, and the teams that are involved need to be public-private partnerships or working with those who have the expertise to do this strategically and in a robust way that inspires confidence, rather. And I think I'll leave it at that, and happy to answer questions later.
Fantastic. Thank you very much, Glenn. And I do see some questions coming in. Keep those coming along as you're listening, and we'll be sure to get to all of those before the end of the webinar. I see one here specifically from Candace that's sort of directed back to PIEVC Youth Program, and we'll certainly get to that after the presentations. So Claire, if you wouldn't mind advancing to the next slide. Here we go. So next we have Abhishek Pokharel. Abhishek is currently with Century Water Control and Monitoring Incorporated in Charlottetown, Prince Edward Island. He completed his MSc at the University of Prince Edward Island and has a bachelor's degree in environmental engineering from Kathmandu University in Nepal. He graduated in 2020, and today he's going to be speaking about work that was completed while he was a Climate Sense intern in 2021 for the city of Charlottetown and the town of Stratford, Prince Edward Island. So I will pass it over to Abhishek.
Thank you, Dan. Greetings, everyone. So I'm Abhishek Pokharel, and I bring you the use of PIEVC High Level Screening Guide use in the Maritimes. So before moving forward, first of all, I would like to acknowledge PEI as the traditional and unceded territory of the Mi'kmaq First Nations, and I'm very grateful to be living and working here, and thank you for the opportunity. So next slide. So as Dan previously mentioned, my name is Abhishek Pokharel. I did my MSc Sustainable Design Engineering from University of Prince Edward Island in Canada. I hold a BTech in Environmental Engineering degree from Kathmandu University, Nepal. So this particular work is done as a climate change infrastructure resilience intern in 2021. So basically, this is my first job. And a disclaimer on to everyone that this is an amateur work, and will be very happy if there is a lot of feedback from every one of you. So, and my current position to talk about is I'm a client manager at Century Water Control and Monitoring Inc. Still working with wastewater. So yeah, next slide. So before moving into the project itself, I'd like to explain a little bit on climate change internship. So it's Natural Resource Canada's under its BRACE initiative. So it is bringing in a recent post-secondary graduate student, someone like me, and hooking them up with public and private sectors in PEI. So in this case, the city of Charlottetown and town of Stratford. And what we do is we work with UPEI, Climate Lab, our host organization, and different other organizations around in the island, and work towards certain sector-specific adaptation projects. During this internship, I was involved in a lot of other projects, green shorelines, coastal hazard assessments for properties and stuff like that. But today I will probably talk on my work with wastewater treatment system in the city of Charlottetown and town of Stratford. Next slide. Next slide, please. Yeah, so I'll just like to start this with the scope. So basically the scope for this project was already defined by the municipalities for me. So they had their climate adaptation plan, climate action plans, adaptation mitigation, and all those plans, which did a lot of risk analysis and all those works. But what I was asked to do on this specific was provide with those values they can use to quantify the cost related energy expenditure and other things that come up with the changing climate. So for this particular study for wastewater, I had two objectives on this. This objective first being analyzing resilience of existing wastewater infrastructure against coastal hazards, which are more towards the town of Stratford, and also looking at the risks that comes to city infrastructure, especially wastewater treatment system and the pumping stations due to the changing climate. Next slide, please. So, introducing the area of this study is the Charlottetown and the Stratford. Stratford is the Triceratops looking projection on bottom right, and Charlottetown is on the top. So just looking at the map, you can see the density of population in these two areas, right? So Charlottetown population is, so Charlottetown and Stratford share a same treatment system since 2021. So Charlottetown and Stratford has combined population of around 50,000, but again, this number changes from 50 to, it doesn't take much to go across 100,000 in summer during tourist season. So there is a lot of those flows, and also there are flows that comes in from unsewer lines like rentals and coast houses. So it's the same. And yep, and the average flow that was detected during this period of study was around 20,000 cubic meters per day. So just a little background on this is Charlottetown has separated its sewer system from stormwater since 2015, and Stratford sewer has its own collection system, but however it sends water over the bridge for treatment, and it pays for per cubic of water that is being sent for the treatment. Next slide, please. So, like I mentioned, it's an amateur work, and I was not very familiar with how to get those climate data and work with it. So I just kind of cheated a little bit on this one. So I did a reverse work. So instead of identifying climates that might impact the infrastructures, what I did was, what are the things from the environment that can impact the infrastructures? One was water outside and inside the pipelines. Inside is basically because of info and infiltrations, and outside coastal hazards, and also an issue with power failures, which is again looked from a different perspective. So with this, when I got this information, I backtracked into finding information on the changing climate and predicted climate with the help of UPEI Climate Lab. So it's putting these two results together and getting something for the municipalities to look at. Next slide, please. So for this, the most important part of this study was gathering of data. So the first part of data is something from historical data. So as I was working for coastal changes, and you might have heard over the news that how Charlottetown, Prince Edward Island has a lot of coastal erosion and flooding issues. We have a lot of our very beautiful beaches destroyed after the recent Fiona event. So it's a big issue in and around PEI, especially, and also in and around Stratford. So what we had, luckily what I had through PEI Department of Environment, Energy and Climate Action was a coastline change since 1968 to 2010. And recently, when I was doing this internship, PEI Climate Lab added to this already established data and brought in data from 2020. So we do have something, measurement of how much erosion did happen, how much mass was added to a beach, and those kind of data. And similarly, there is also resources on different shore types around PEI, especially around. So I use this data in and around Charlottetown and Stratford area to determine what kind of shoreline this is. Is it a salt marsh? Is it sandy beach or something, or what is the probability? So this kind of helps me to identify the probability of the particular shoreline being eroded. Next slide, please. So on top of that, I needed some predicted data, right? So through PEI Department of Environment, Energy and Climate Action, again, and in collaboration with PEI Climate Lab, we have something called Coastal Hazard Information Platform. So this is a screen that I have put screenshot of the platform that we can get. And you might see on the left side, you can see some parameters that we can see being laid over the maps of Charlottetown and Stratford. So basically, we have predictions for high flood hazards for 2020, 2050, and 2100. So based on different level of hazard intensity, we can use this map for analyzing post-hazard assessment. Next slide, please. And finally, so to talk about info and infiltration, what I did was, so I learned sanitary sewer overflow analysis and planning toolkit from US EPA, and UPEI Climate Lab had established local weather stations in and around Charlottetown, so got data from them, and using this to data and computer programming, what I did was I tried to model the sewer system of Charlottetown as well as Stratford and gather data on how the rainfall is affecting this particular sewer network. Next slide, please. So, and the secondhand data, I think this is one of the most important resources of data that I could think of. So these were the data, informal data, as I like to call it, secondhand, I got from traveling with operators on the truck when they were doing maintenance and everything. So asking them a lot of questions, what's happening, what happened there, why this pump station down, what happened in 2015, what happened in 2018, and things like that. So this was a lot of helpful. So this kind of helped me to identify those vulnerable areas, the vulnerable assets like pumping stations, those old 1970s, 1980s pipeline system, those old houses that had that doesn't have a sump pump and connects it directly to the sewer network and those kind of stuff. So yeah, this was a great source of data as well. Next slide, please. So on the step, now the third step of this process was assessment. So on this part, so for the coastal hazard assessment, what I did was with the secondhand data and all that information, identifying the important and most vulnerable pump stations in and around Stratford. So on the left figure, you can see a little red triangles. These were the pumping station which serviced a higher number of population and were very vital for the whole treatment, the whole collection system. So based on the data that I had previously from on coastal chains and flood hazard, I overlaid on GIS with these locations and identify infrastructures like pumping stations shown on the right side. One of the stations called Bayside, which is very close to the shoreline and in the flood zone. This is because this is one from back 1970s or 80s pumping station, and people used to build it very close to the, it was built very close to the coastline because of the natural gradient that it had. So, but it kind of looked a little problematic now. So next slide, please. So similarly, when I identified these vulnerable infrastructures and pumping stations, I forwarded this to the Department of Environment, Energy and Climate Action. They have an assessment process called Coastal Hazard Assessment. So what we do is I send the property number for the party where this infrastructure is located, and they do a coastal erosion hazard assessment and coastal flood assessment for that particular property. And this is one example for the Bayside that I just mentioned before. So you can see that for the high flood hazard, it's 35% of the land falls under it, and the minimum is at least 10% of it falls when there is a high tide. There's a storm surge during a high tide. Next slide, please. In addition to that, this is where I also carried out rainfall data info and infiltration analysis for the main treatment plant, which is on the left side, and also for the individual sewer shed for a pump station, which is on the right side. So on the left side, we have a wastewater treatment system inflow at the wastewater treatment plant. We can see a significantly high inflow and infiltration during one of the biggest rainfall on 2nd of September 2021 with 128 mm of rainfall. And if I'm not wrong, this is the second highest recorded rainfall ever on any place in PEI. And similarly, on the right side is the same day, but for Stratford. One thing I'm not sure how clear the graphs are, but one thing that we can see is on the Stratford, and it's more of like a quick rise due to the rainfall, which kind of says that it's more of like inflow issue rather than infiltration. Whereas for Charlottetown, it's more of inflow and infiltration both. What this information does is it prevents Stratford from digging out their pipes and doing the coating. Instead, they can do a simple smoke test and identify the places of inflow. But for Charlottetown, they have to divide their whole sewer network into different sewer shed and identify each one individually. So from this data, I got a few numbers. So I didn't mention, apologies for that, I didn't mention exact number because I thought this was not very professional. So I can give you the numbers if you are interested on this one. But yeah, this much mm of rainfall per hour has significant impact on microbiology of the treatment. This was, I think, 17 mm of rainfall. Anything above or around that causes microbiology imbalance in the treatment unit. Similarly, for Stratford, for Charlottetown, I remember it's 10 to 12 mm per hour of rainfall. And finally, for Stratford, it was around 10, similarly 20, which was the threshold for the treatment. Next slide, please. Yeah, so for the risk analysis, again, based on these assessment, I got those numbers and the climate parameters that can impact infrastructure. So what I did was collaborated with institutions like UPEI for predictions and identifying severity, climate change, and impacts. So what I did was I calculated utilizing power resource and what power was used, how much extra power was used because of this extra flow coming in, decrease in pump run hours, irrigation, excess irrigation, and all that stuff, and also compare the cost of operation, decommission, and failure of the cost of that. So next slide, please. So on this part, so on this whole risk estimate, I came up with three important concerns. One was one pump station that I showed before had a moderate risk of coastal flooding and overloading. Second was a moderate to high risk to rainfall data inflow infiltration in Charlottetown, and a low risk for RDII for Stratford. Next slide, please. So for now, what we see that pump station, I suggested with short-term measures against coastal hazard, but as of now 2020, they had to build a new station to decrease the load for that particular pump station and doing work on that. Similarly, Charlottetown is working on its assets management and doing a master plan for the wastewater treatment. And for the Stratford, they brought in the bylaws for stormwater connections and pump connection into the system. And finally, for power failures, I just worked with some emergency response and backup power options with operators and the municipality. So next slide, please. yeah, I think I'm done with it. And thank you very much. I'll be more than happy to answer any of the questions.
Great, thank you very much, Abhishek. Very interesting case study from Atlantic Canada. And it's also good to hear from Abhishek as a new professional in this area, and we'll be very happy to get his thoughts as a new user of the PIEVC process and somebody who is relatively new to the adaptation space, climate risk assessment space when he did this work recently. So thank you again, Abhishek, and we are going to move on to Lindsay Allen. So Lindsay Allen is a climate resilience engineer in CBCL St. John's, Newfoundland and Labrador office. She specializes in climate change risk assessment and adaptation planning to support a wide variety of industry sectors, including transportation, natural resources, new and existing infrastructure, and municipal planning. She has extensive experience in facilitating stakeholder consultation and is passionate about incorporating local perspectives and expertise in a climate risk assessment and adaptation planning to develop practical and innovative solutions. Throughout her career, Lindsay has worked in a variety of fields, including geotechnical and environmental engineering, contaminated sites investigation, mining, oil and gas, and government, allowing her to bring a wide variety of knowledge and depth to her risk assessment work. And so we're very happy that Lindsay's made time to talk to us today, and I'll pass it over to her.
Thank you very much, Dan. Very happy to be here. So like Dan said, I am in St. John's, Newfoundland. So before I start, I would like to respectfully acknowledge the territory where I'm presenting from today as the ancestral homelands of the Beothuk, and the island of Newfoundland as the ancestral homelands of the Mi'kmaq and Beothuk. I would also like to recognize the Inuit of Nunatsiavut and Nunatsiavut as the Innu, and the Innu of Nitassinan and their ancestors as the original people of Labrador. So like Dan said, today I'm here to present on a climate risk assessment using the PIEVC High Level Screening Guide that we are doing at CBCL for bridge infrastructure in Ontario. So this project is for the federal government. Before I start, I do just want to point out that this project is a confidential project, so I can't get into really specific details on the infrastructure and locations and things like that. But basically, what I'm here to present on today is just a fairly straightforward case study on how the high-level screening guide can be used to assess risk to infrastructure. So next slide, please. So a little bit of background on the project. So as some of you may know, the federal government of Canada has some various targets and goals related to incorporating climate resilience into their real property assets. So that's really where this project stems from. So basically, PSPC, Public Services and Procurement Canada, engaged CBCL to conduct climate change risk assessment for 3 bridges in Ontario to inform their ongoing operations, any future upgrades they may have planned, and just general long-term plan and asset management. So we're looking at 3 bridge sites throughout Ontario and 3 different types of bridges. So one site is your typical, I guess, lift bridge. The deck of the bridge just moves vertically up and down. The second site is what we call a bascule bridge. So a bridge that sort of rotates on a hinge at one end to let marine traffic through. And one is a more typical span bridge, just a metal truss bridge, no movement involved. And what's interesting about this project and the application of the high-level screening guide to this project is that each of the sites consist of multiple assets. So there are the bridges themselves, there are buildings, there are electrical, mechanical equipment, lots of different things to consider here. So it's a great application to include all of those things to inform asset management from a high level perspective. Next slide, please. So basically, like I said, I'm just going to walk you through the application of the high-level screening guide for this project. So we followed the steps of the high-level screening guide pretty closely. I will also say that the project isn't quite finished. We're currently in the recommendations of reporting phase. So I will sort of speak to what we've done so far, but step 1 was essentially the scoping part of the assessment. So that's where we just tried to break down the assets, figure out how we wanted to group things and score things. at each site. Step 2, the climate analysis and impact assessment. So that's where we get into likelihood scoring and characterizing our assets. Step 3 is the actual risk assessment. So finalizing the severity scores and calculating our overall risk profile. And then step 4, like I said, that's where we are right now, recommendations and reporting. And of course, the overall goal is to sort of complete the formula below, identify which assets are exposed to a climate hazard, the probability of those climate events or hazards occurring, and of course, the severity of potential impacts. All that comes together to calculate your overall risk. Next slide, please. So I'll dive into each of the steps a little bit. So like I said, 3 bridge sites located throughout Ontario. That's the main focus of the project. And each site can be sort of described as a portfolio of assets. So at each site, we have the main bridge itself. We have coastal infrastructure such as wharves and guide walls that direct marine traffic. We have supporting buildings, whether it be offices or warehouses, electrical and mechanical equipment that support backup power or the actual lift function of the bridges. And then something interesting about one of the sites that we're looking at, we're also including contaminated sites as its own sort of asset. So in this case, we're looking at the different contaminants that are present from a historical contaminated site, and looking at how various parameters, climate parameters, could impact future migration or changes in concentration of the contaminants that exist there. So like I said, a very wide portfolio of assets. So one of the first steps was to sort of break that down and figure out how we wanted to divide the assets for scoring purposes. And I'll show you a little bit more into that on the next slide. So something else that's a little bit unique about this this project is that because there are so many assets, we have a number of different stakeholders to deal with. So PSPC themselves, as well as other government departments such as Department of Fisheries and Oceans and Environment Canada, specifically as it relates to the contaminated sites portion. And as well, our team internally at CBCL is quite large, and we have a lot of different disciplines involved. So the risk assessment specialist, that's myself in this case, as well as a couple other risk assessment professionals. We have a few climate specialists on the team to actually do the projections. And then we have subject matter experts from a bunch of different disciplines. So structural, civil, bridge engineering, mechanical, electrical specialists, coastal specialists, contaminated sites specialists. We have a ton of different people on our team so that everybody can really evaluate those risks appropriately. Next slide, please. So like I said, sort of the first, I guess, phase of the first step of this project was to figure out how we wanted to separate our assets here. So it's maybe a little bit hard to read here on the right, but essentially we took each individual site and we broke it down into its key assets. So in this example, we have bridge site 1. We broke that down into marine structures, the actual lift bridge itself. In this case, we had a couple of additional smaller concrete bridges that support sort of a full causeway system. Like I said, we had some buildings, and then we grouped just general site features together, such as traffic control systems, civil systems like drainage features, for example, emergency power. So you can see under each of those main asset categories, we then broke those down into different elements. So the different wharves we're looking at, guide walls, abutments, all of those under the marine structure. Under buildings, we have the buildings separated out. And then even further to that, it doesn't quite fit on the slide here, but we broke each of those elements down into sub-elements for scoring. So that's where things like the electrical mechanical systems of the building come into play, or the electrical mechanical systems of the bridge, or of course, there's different components to the bridge, such as the deck and various other elements. So each of those things are broken down even further for the scoring. Not part of the assessment. Also in step 1 in this scoping phase, in my opinion, one of the most important steps at this phase is to really define your performance response factors. So that's the type of impacts essentially that we're going to be assessing for this project. And that can vary from project to project, depending on the needs of your client. So in this case, we looked at a bunch of different things. So we're looking at potential structural impacts, impacts to operations, so day-to-day operations of the bridges, economic impacts, as well as impacts to health and safety and regulatory impacts. So there were a lot of different things to consider here. Again, it's very project specific. In some cases, we'll just look at one element, maybe just structural components or health and safety. But in a lot of cases, we do look at a real variety of performance response factors. And again, this is where the high level screening guide comes into play. You can, when things are assessed at sort of a higher level, you're able to dive into more of these performance response factors and assess a real variety of things. And lastly, in the scoping phase, we assigned our time horizon. So in this case, we have, of course, the baseline period, the 2030s, 2050s, and 2080s. So of course, this is transportation infrastructure, so it's expected to be around for a long time. So that's why we're looking well into the future. But like I said, because there are so many different assets and components and elements at this site, we also want to look at incremental time horizons to make sure we can capture the lifespan of all of these different elements. And some elements have a life cycle of maybe 15 or 20 years before they're replaced, whereas other elements maybe 50 or more years. So those time horizons cover all of those things. Next slide, please. So step 2 is the climate and impacts step. So this is where we dive a little bit more into the details. So first of all, we do our data gathering to characterize assets. So each of those assets and elements and sub-elements that I spoke to earlier, we look at background data that's provided by the client or through research to understand those assets. And what we're looking for there is things like thresholds, or any other operational parameters that we can use to define what climate parameters we want to look at. So in this case, we looked at engineering drawings and reports, life cycle analysis, planned upgrade, any plans for upgrades, feasibility studies, options analysis, a bunch of different background documents. And anywhere where there were a few instances where we were missing some data. So to supplement that or to fill those in the gaps, we conducted a site visit to each of the bridges and we developed questionnaires to send to the actual bridge operators to get their perspective from sort of their day-to-day operations and the people on the ground. So then we move into the climate analysis, and this is where that exposure element of the PIEVC process and calculation comes into play. So what we did here was we identified the relevant parameters. Like I said, that was just through having a general understanding of the climate region as well as understanding the performance thresholds of the bridges. So for example, if the bridge is only able to lift in winds greater than 80 kilometers per hour or less, that could be a performance threshold that we might look at. We might evaluate that climate parameter. And then we go through each of the climate parameters that are relevant and we sort of assign interactions. So we determine which assets could potentially be exposed to a particular climate parameter, and any climate parameters that have that exposure element for one or more assets, we move forward with projections and likelihood scoring. Next slide, please. So just at a high level, these are sort of the 4 categories of parameters that we're looking at. So we have parameters related to precipitation, water levels, winds, temperature, and as well as some combination events. So those are things like wind-driven rain, hurricanes, rainfall and freeze. Those things where more than one climate process comes into play. Next slide. And just a high level overview of some of the impacts that we looked at. We looked at things like flooding, pressure imbalances, corrosion, potential operational disruptions, so short and long-term closures. I won't go into all of them, but like I said, something that was kind of consistent across most of the categories was contaminant migration or transport, and power outages was another big one that we looked at throughout all these different parameters. Next slide. So to conduct our likelihood scoring, we used primarily the middle baseline approach that the PIEVC High Level Screening Guide outlines. I won't get into it too much, but essentially that's a process that we use for most climate parameters. In some cases where we had, say, return period data, we did develop sort of accompanying scales that would be based on return period data. So for example, we would look at the 1 in 100 year rainfall event and look at how that might change and become something more like the 1 in 50 or the 1 in 20 or something like that in the future. And we would assign likelihood scores accordingly based on that. And most of our data came from either climatedata.ca, Environment Canada, literature review, or one particular report we use quite frequently is this Canon report from 2020 that discusses climate change for built infrastructure. Next slide. Step 3, this is the actual risk assessment component. So this is where we dive into the actual scoring and communicating with operators to make sure our scores are correct, our consequence scores or severity scores. So in this case, we had our preliminary scores assigned prior to hosting a series of workshops with the bridge operators. And we used the workshops to confirm those scores, get input from the operators to make sure that everything was, everybody was sort of on the same page. And what we did, the PIEVC High Level Screening Guide, of course, outlines sort of a 1 to 5 scale that gives you a lot of flexibility in how you want to use it. So what we did was essentially took each of our performance response factors. So you can see across the top of the table there, we have operations, structural integrity, financial, and we sort of assign different impacts under each of those performance response factors into the 1 to 5 scale to help us facilitate that discussion and assign scores in the workshops. And after that, it was pretty straightforward to just calculate your overall risk profile. Again, I can't show that here today, but that was the next step. And then anything that is falls sort of within that moderate to high risk category moves forward for recommendations. So next slide. So like I said, this is the phase we are at right now. Anything with a score of 10 and above, we will consider for developing recommendations for adaptation. So some of the potential types of recommendations that we might be looking at are specific infrastructure upgrades, modifications to operational plans, potentially scheduled monitoring, cyclical maintenance schedules, changes to emergency planning or development of emergency planning, and implementing communication protocols between all the relevant parties to make sure everything's on the same page. And I believe that is it. Next slide. That's all. Thank you very much.
Great, thank you very much, Lindsay. And thanks everyone for offering comments and questions during the presentations. So we'll move into a quick discussion period here. So if Lindsay, Abhishek, Glenn, Quentin, you wouldn't mind switching on your cameras. We've got a few questions that have come in, but actually some of the questions that have come in were consistent with some of the questions that were raised to presenters during the last webinar. And specifically, there are quite a few questions about the middle baseline approach. And of course, Quentin, you talked about it in detail and its advantages working in the municipal context specifically. And I thought it was helpful last time for some of the presenters to really briefly walk through the process that they went through to assign those likelihoods using that middle baseline approach. How did you sort of overcome uncertainty? How did you deal with potential disagreements with folks in workshops and that sort of thing? So maybe we'll start with Quentin, and then we'll have Lindsay and anybody else who'd like to comment.
I was going to say, Dan, that we started off with 9 climate hazards, and once we went through the process to identify where there were high and very high risks, we actually came back down to 6 climate hazards. So when we actually applied the probability scale to the 9, it was pretty clear cut where based on the climate data portal was our default portal. We're very fortunate that in the area around the community we're working with, in the case of the city of Guelph, Waterloo and other communities. Pearson Airport is not that far away. A lot of detailed information to sort of balance out the climate data portal information. So we had a pretty strong confidence in what those projections were for 2050 and then 2080. And then when you apply them to the plus or minus 10%, the 10 to 50%, 50 to 100%, it becomes pretty clear cut. And where there is a little bit of variability really came down to how one articulates, let's say, acute weather events based on some low probability, high impact, or just uncertainty around the science behind it. And then it gets a little bit more fuzzy as you're trying to deal with lightning versus high wind gusts versus hail. So you may have to differentiate those. But at the end of the day, you end up with 6. And that's where, in the case of Southern Ontario, and one of the other participants raised the question correctly that in Edmonton, freeze-thaw cycles are actually increasing. So in Southern Ontario, they're decreasing. And so the point of my mention of that is that just because it's decreasing and then it no longer becomes a high or very high risk, doesn't mean to say that it's not still very important to municipal decision makers. Because for the foreseeable future, certainly in the next 5 and even 10 years, freeze-thaw is going to continue to pose the same problems on potholes than it has in the past. So this is all about incremental change and relative change, that delta change that climate change is going to create. And so the focus tends to be more on where do we need to invest more money, so where those risks and likelihoods are going to increase, as opposed to where we are going to accrue savings by avoided costs or avoided expenditures. So that was really what was coming out of the conversation. And just take that for what it is.
Great, thank you. Lindsay?
Yeah, so it's interesting for this application. We obviously have a lot of different climate parameters that we're looking at. So that middle baseline approach, we use that as much as possible and find it very straightforward for a lot of parameters. One area where we do tend to develop scales that sort of align with the likelihood scoring methodology is for extreme events. So for example, something like a tornado, we don't necessarily want to assign that the same likelihood score as something like freeze-thaw cycles, which occur, daily, very regularly. So when we get to those extreme events, whether it be, like I said, tornadoes, hurricanes, even extreme rainfall events, we develop scales that the baseline tends to start more around the 1. So it's not necessarily an extremely likely event or occurrence, and then we work up from there. So like I said, with the return period data, if we have that for a certain parameter, say an extreme rainfall event, we might look at, say the 1 in 100 year rainfall event could be our score of 1. And then as we look at that return period data and how that's going to change, so it's something, like I said, becomes more like a 1 in 30 year event, or like a 1 in 5 year event, that would be a big change. But you know what I'm saying? We would sort of adjust our scale based on that. So your score of 1 could be around the 1 in 100 year event. Maybe your score of 3 is the 1 in 50 year event, and your score of 5 could be an annual event. So we would look at how that return period is changing and then score based on that. So that's sort of one way we get around extreme events and apply that methodology.
Okay, great, understood, thank you. Yeah, Glenn, you're nodding your head a fair bit there, wondering if you had some thoughts you wanted to get out.
Just, yeah, I very much agree with the comments from both Quentin, and just in general, I would say one thing we have to, I often have to caution or caveat with the likelihood approach when it comes to private sector real estate clients is they tend to focus too much on financial damages, which comes into factor as to result of the consequence piece, not the likelihood of the climate hazard piece. And so that's often a conversation to clarify. They'll often, for example, suggest that we know our most damaging hazards across North America. We know that they are flood-related, heat-related, wildfire-related, tornado-related, for example, or extreme wind-related, without thinking through the likelihood and how that may shift per region. That's all that I was going to add to that. So it's pretty important to think about archetypes and how many regions is appropriate for an assessment. Yeah.
Great, thank you. So Abhishek, you mentioned in your presentation a few times that your work was part of an internship. And one of the reasons why we wanted to have you presenting is because of your perspectives or perspectives you could offer from sort of a new user or somebody that's new to the field. So if you could maybe just sort of elaborate on how you came across the PIEVC approach and why it was selected, and maybe some of the responses from your clients, Stratford and Charlottetown, with respect to outcomes of your process. That'd be good to hear.
Yeah, sure, Dan. So, like I mentioned, I started this thing as an intern, so I was looking for something to get me through this internship to identify climate adoption, everything. So, a lot of search and looking at it, and stumble upon Climate Lens. Going through, you used to get PIEVC protocol. I think I sent you. So get the PIEVC protocol, and I was just walking through it, and unknowingly, I was kind of doing the high level guide because I couldn't go that deep because of my timeline. Still, I don't have access to a lot of data. So yeah, that was hard, and it's a very good. One of the very good aspect of it was there was a lot of literature available for me. So if I'm just going through the thing, and if I wanted to look into some, there are a bunch of examples from BC, especially in and around Vancouver, and a lot of those which I can relate and what was needed or what people were doing. And yeah, that was one of the things. And one of the aspects that I find with this one is it's very good for municipalities and especially for the council members, because eventually the money that's going to come into infrastructure is through Infrastructure Canada and those kind of stuff, right? And when you put these guidelines there and say, this is how they will evaluate your proposal, and given that value of money and that value to the climate change impacts, like I said, I mentioned 30% of increase in flow in the wastewater causes this much energy extra and those kinds. So they knew that they had part of a lot of these discussions with RICS and everything. So when these numbers comes up and when they say this is what a lot of the stakeholders look at, so they're very happy, and I think they are trying to bring in, not completely, but at some point I've seen them doing it in different proposals I see or here and there, or different things I hear from the friends. They are bringing it into their implemented procurement process, or even taking some decisions on few infrastructures in and around the municipality.
Great, thank you very much, Abhishek. So we have some questions here from our attendees. And one question, I think, maybe it's related to what Glenn was mentioning about some of these climate tech companies that are coming online, and we may see them more involved in these types of assessments, for better or for worse. And so there's a question from Anna Hamid to any presenter. Have any of you encountered discrepancies, contradictory climate data from different jurisdictions, national, provincial, municipal? And if so, which source was chosen and why? So I think maybe turning back to Quentin, sort of from your long history in working in this area, if you could comment on this question, but also maybe some of what Glenn had mentioned about some of these climate tech companies. Are you seeing these groups having more, I guess, participation in work that you're involved in, or how do you see them coming into play, and how do you sort of see that affecting potential disagreements in data?
Boy, oh boy, you're really putting me on the spot, aren't you? I can't deflect this to Lindsay or others anyway. Okay. The timing couldn't be more ironic or correct insofar as I've had a recent encounter with a service provider. And without pointing them out specifically, I would concur that, yeah, there's an explosion of those hanging up their shingles and their signs saying that they're experts. And with the proliferation of information and data, and then of course you bring in the AI component, which is a whole different conversation. There's just so much that's out there. And so, what one tries to do, I think, for most of us working in this field, and certainly relying upon PIEVC protocols, to make sure that it is transparent, that it is evidence-based, and it's scientifically defensible. And there's a big thrust in Canada, of course, through the Canadian Centre for Climate Services. And we just did a conference a couple weeks ago on business continuity planning and emergency management, where we're educating that community. And one of the key speakers was Ryan Smith, who was from the Canadian Centre for Climate Services, and talking about the climate data portal. So whether or not, looking at Canada, what is becoming more universally accepted as the default for climate information, or to the degree that, and I note that they've actually upgraded to consider CMIP 6 as part of their scenarios, and then the shared social economic pathways. And so, I think there is a certain standard that we're all sort of expecting that's becoming more universally applied, whether or not you're working in Australia, working in the UK, or working in Canada. They're all sort of meeting that same level of standard. So it'll be interesting to see, really, from a private sector perspective, what is in their black box, what is their magic that they add value to this information that is already accessible to a majority of us practitioners, that gives us that competitive edge if we're dealing with it in that context, or for the purposes of our stakeholders, where there's information that's either temporarily or spatially granular that is important to the client, because that's ultimately the holy grail, is getting the information matched with the needs of the client. And what you don't want to do is be in a situation where you're spending too much time, too many resources, and over-promising information, when in fact, a little bit of information or a simple depth of information is all that's required for an analysis, or the opposite, where a much deeper dive is needed.
Great, thank you, Quentin. Your perspective is very appreciated on that topic. So along the lines of climate data, we had a specific question for Lindsay. So we have about 3 minutes left. I'm hoping to get one more question to Lindsay, Glenn, and Abhishek. So maybe if we can go around relatively quickly. I have 2 questions for Lindsay. One is your source for wind-related climate data. And the second one is, could you expand a little bit? You mentioned part of your assessment included economic impacts associated with the bridges you're working on.
Yeah, absolutely. So when it comes to wind, I'm guessing this question is raised because it's difficult to find wind data, or it's not extremely well established versus something like temperature or rainfall. So I won't speak for our climate scientists. They're absolute experts in this field, but I know that our wind data typically comes from literature review. Again, I don't want to quote the exact source because I don't want to get it wrong, but we do take our wind data typically from literature, at least when we're dealing with Canadian projects. And a little bit on the economic analysis. Again, it can be very client dependent, specifically when we're talking about federal government work. One thing that we have been doing in some of our recent projects, we tend to do a lot of work for the federal government, is we try and sort of classify impacts based on whether or not an impact would trigger, say, a major capital project, or it could be just dealt with using sort of day-to-day funds that are already available, or we kind of have a scale developed for that. So that scale ranges, like I said, something that might disrupt, or something that might fall within the category of, even if it is a slight impact, it kind of falls within the category of day-to-day operations. So, maybe you're out doing ice clearing, snow clearing, that's already in your budget. And then that scale from 1 to 5 goes up to something like, a complete rebuild of an asset in a particular extreme climate event, say. So that's kind of how we take economics into consideration.
Great, thank you, Lindsay. Glenn, in a few 30 seconds or so, a specific question. Sorry about this, the shortness of time, but you say 2 out of 10 generally of the clients that you're kind of working with in your industry have more dedicated plans or funded plans for adaptation. Is there anything consistent about those clients? Are they coming from a specific sector?
That's a great question. I would say not from a specific sector. I would certainly say what probably ties them together is the idea that leadership kind of is providing and demonstrating value to their asset owners and their occupiers, so they're seeing demonstrated results. I would say they're really trying to focus on leading in the space, I would say, but we work with people, I would say, at leading edge all the way to those who are avoiding disclosure and reporting on certain issues. So it depends on the conversations, and we try to find entry points at any stage of where someone's at. And we tend to try to find those who are kind of trying to lead or coming in second and third kind of thing as it relates to adaptation and risk assessment. So, yeah.
Great. Okay, thanks, Glenn. We're actually at 2:30. Abhishek, I had a question for you specifically about sewer separation in Charlottetown, a little bit due to my interest in I&I in general. We may have to get to that on the practitioner's site because we should wrap up here. And I just want to say once again, thanks everyone for the time that you offered to us today. We had a great crowd, lots of good questions, and we're really happy that you were willing to participate. And hopefully we can continue hearing from you as we go forward in the PIEVC program. You're certainly some of our most important stakeholders and supporters. So thank you again. A quick note that the next webinar will be on February 16th. That will focus on a new PIEVC product, PIEVC Green. It will be hosted by GIZ, who led development of that resource. So please check out or register for that with the information that Claire's provided in the past. And a reminder to join the practitioner space, and Claire's provided a link for that. And that's to continue these types of discussions online, and we look forward to seeing everyone there. And I should also mention Christine Calhoun. Thank you for all of your ongoing comments in the chat and perspectives. We really appreciate that. And I think we're going to wrap it up there. Thanks again, everyone, for joining. And thanks again to our presenters.